What if I told you that beneath 2 miles of crushing ocean water, something has been waiting for us for over 11,000 years? What if the most famous lost civilization in human history wasn't just a story Plato made up to teach philosophy, but a real place with real people who built real cities that we're only now beginning to find? In March 2024, a team of marine archaeologists using cutting-edge sonar technology made a discovery off the coast of Spain that has sent shockwaves through the scientific community. They found geometric structures on the ocean floor that shouldn't exist. Not at that depth, not at that age, and definitely not with that level of sophistication. Massive stone circles, perfectly aligned corridors, and what appears to be an entire city complex buried beneath sediment that's been accumulating for millennia. But here's where it gets really interesting. The dating methods they used suggest these structures are far older than any known civilization. We're talking about a time when most of human history tells us people were still figuring out basic agriculture. Yet these underwater ruins show evidence of advanced engineering, precise mathematical planning, and construction techniques that rival anything we see in ancient Egypt or Mesopotamia. Now, before you roll your eyes and click away thinking this is just another conspiracy theory video, let me be crystal clear about something. I'm not here to tell you that aliens built Atlantis or that there's some massive cover-up happening in the scientific community. What I am here to do is walk you through the actual evidence, the real technology being used, and the genuine debates happening right now among serious researchers who are trying to figure out what we're actually looking at down there. My name is Alex, and I've spent the last 3 years investigating underwater archaeology discoveries around the world. I've interviewed marine geologists, ancient history experts, and the actual researchers who are down there in submersibles taking these scans. What I've found is that we're living through one of the most exciting periods in archaeological history, where technology is finally allowing us to see parts of our planet that have been hidden for thousands of years. And what we're finding is forcing us to reconsider everything we thought we knew about early human civilization. But first, let's talk about what Atlantis actually was according to the only source we have, Plato himself. Because here's the thing that most people don't realize. Plato wasn't writing fantasy. He was a philosopher, yes, but he was also obsessed with historical accuracy. When he described Atlantis in his dialogues Timaeus and Critias around 360 BCE, he presented it as a historical account that had been passed down through generations. According to Plato, Atlantis was a naval power that existed about 9,000 years before his own time. That would place it around 11,600 years ago, right at the end of the last ice age. He described it as being larger than Libya and Asia combined, located beyond the Pillars of Hercules, which most scholars agree means somewhere past the Strait of Gibraltar in the Atlantic Ocean. The Atlanteans, according to Plato, had developed an incredibly advanced civilization. They had sophisticated agriculture. They built in concentric circles with alternating rings of water and land. They had hot and cold running water, and they possessed bronze, gold, and a mysterious metal called orichalcum that was supposedly more valuable than gold. Their military was so powerful that they had conquered parts of Europe and Africa before eventually being defeated by ancient Athens. Then, in a single day and night, the entire civilization disappeared beneath the waves due to earthquakes and floods. For over 2,000 years, most scholars have treated this as either a complete invention by Plato or at best a heavily mythologized account of some much smaller historical event. The general consensus has been that Plato created Atlantis as an allegory, a cautionary tale about the dangers of hubris and the inevitability of civilizations that grow too powerful and corrupt. But what if that consensus is wrong? What if Plato was actually trying to preserve a real historical memory that was already ancient in his time? This is where modern technology starts to get really interesting. See, for most of human history, the deep ocean was completely inaccessible to us. We knew more about the surface of Mars than we did about the bottom of our own oceans. But in the last 2 decades, that's completely changed. We now have autonomous underwater vehicles that can dive to depths that would crush any human instantly. We have side-scan sonar that can map the ocean floor in incredible detail. We have sub-bottom profilers that can literally see through layers of sediment to reveal what's buried beneath. And most importantly, we have artificial intelligence that can analyze massive amounts of sonar data and identify patterns that human eyes would miss. It's this combination of technology that's allowing researchers to systematically search vast areas of the ocean floor for the first time in human history. And what they're finding is that the ocean floor is not the barren, featureless landscape that many people imagine. It's full of mountains, valleys, plains, and yes, structures that appear to be artificial. Now, here's where I need to pump the brakes for just a second. When I say artificial structures, I don't automatically mean built by humans. The ocean floor is a dynamic environment. Underwater volcanic activity, tectonic shifts, and millions of years of geological processes can create formations that look geometric, organized, even planned. The first rule of underwater archaeology is that nature can be incredibly deceptive, but there are ways to tell the difference. Natural formations, even when they look artificial, tend to follow certain patterns based on the geological processes that created them. Human-made structures have different characteristics. They show evidence of quarrying, of deliberate placement, of materials that have been moved from their natural locations. And this is where the recent discoveries get really compelling. In 2022, a research team led by Dr. Maria Santos from the University of Cadiz was conducting a routine geological survey about 60 miles southwest of the Spanish coast. They were using a state-of-the-art multi-beam echo sounder system to map the seafloor topography when they started picking up anomalies. At first, the data looked like it might be natural rock formations. The area they were scanning sits on what's called the Iberian Abyssal Plain, about 2,300 meters down. That's over 7,500 feet beneath the surface. It's a region that's been geologically stable for millions of years, covered by a thick layer of sediment that's been slowly accumulating since the last ice age. But as they processed more of the data, patterns started to emerge that didn't fit with natural geological processes. The first thing that caught their attention was a series of perfectly circular formations, each about 100 meters in diameter. These weren't scattered randomly across the seafloor. They were arranged in a clear geometric pattern, with consistent spacing between them. Natural processes don't typically create that kind of regularity over such a large area, but circles can sometimes occur naturally, especially in volcanic regions. What really made the team sit up and take notice was what they found when they looked more closely at the data. Connecting these circular formations were what appeared to be straight lines, corridors or channels that ran for hundreds of meters in perfectly straight lines, intersecting at right angles. Some of these linear features were raised above the surrounding seafloor, like walls or ridges. Others appeared to be channels or depressions, as if they had once carried water. The whole thing looked, in the words of one team member, like someone had drawn a city plan on the ocean floor. Now, Dr. Santos and her team are serious scientists. They know that extraordinary claims require extraordinary evidence. So they spent the next several months ruling out every possible natural explanation they could think of. Could these be the result of underwater volcanic activity? Unlikely. The area shows no signs of recent volcanism, and volcanic formations don't typically create the kind of geometric precision they were seeing. Could they be the result of tectonic activity? Again, unlikely. While tectonic forces can create linear features, they don't typically create the kind of organized, interconnected patterns that showed up in the sonar data. Could they be the result of underwater currents carving channels in the sediment? This was more plausible, but the team found several problems with this explanation. First, the linear features appeared to be buried beneath layers of sediment, suggesting they were much older than any current patterns in the area. Second, the geometric precision and right-angle intersections were unlike anything typically created by water flow. As they continued to analyze the data, more intriguing details emerged. Some of the circular formations appeared to have internal structures, smaller geometric shapes within the larger circles. The linear features weren't all the same width or height. Some appeared to be major corridors, while others looked like smaller connecting pathways. Most intriguingly, when they used sub-bottom profiling to look beneath the surface sediment, they found evidence that these features extended much deeper than initially thought. The structures weren't just sitting on top of the seafloor, they appeared to be partially buried beneath thousands of years of accumulated sediment. This suggested something that sent chills down the spines of everyone on the research team. If these really were artificial structures, they were incredibly old. The rate of sediment accumulation in that area of the Atlantic is well understood. For structures to be buried as deeply as these appear to be, they would have to have been on the seafloor for at least 10,000 to 12,000 years. That timeline should sound familiar. It's almost exactly the time frame that Plato gave for the destruction of Atlantis. But before we get too excited, we need to talk about the elephant in the room. Even if these structures are artificial, even if they're as old as the sediment analysis suggests, that doesn't automatically mean we've found Atlantis. Ancient civilizations built things all over the world. Just because something is old and underwater doesn't make it the specific lost civilization that Plato wrote about. However, there are some details about this discovery that line up remarkably well with Plato's description. The location, for instance. Plato said Atlantis was located beyond the Pillars of Hercules, the Strait of Gibraltar. This discovery is in the Atlantic Ocean, west of the Strait of Gibraltar, exactly where Plato said it would be. The timeline also matches. Plato placed the destruction of Atlantis around 11,600 years ago, right at the end of the last ice age. The sediment analysis of these structures suggests they've been underwater for 10,000 to 12,000 years. But here's perhaps the most intriguing detail. The circular patterns found in the sonar data bear a striking resemblance to Plato's description of Atlantis as a city built in concentric circles, with alternating rings of water and land. Now, I want to be very clear about something. Dr. Santos and her team have not claimed that they've found Atlantis. They're much too careful as scientists to make that kind of leap. What they have said is that they've found structures on the ocean floor that appear to be artificial and are much older than any known civilization in that area. But the discovery has caught the attention of researchers around the world, and follow-up studies are already being planned. Advanced underwater vehicles are being prepared to physically visit the site and take direct samples of the structures. Ground-penetrating sonar will be used to create even more detailed maps of what lies beneath the sediment. And here's where things get really interesting, because this isn't the only underwater discovery that's been made in recent years that challenges our understanding of ancient civilizations. In the summer of 2023, a team of researchers working off the coast of Turkey made a discovery that initially seemed unrelated to the Spanish findings. But when you look at the details, some fascinating connections start to emerge. Dr. Kemal Özkan, a marine archaeologist from Istanbul Technical University, was investigating what appeared to be a natural underwater ridge formation in the Black Sea. His team was using a new type of synthetic aperture sonar that can penetrate deeper into sediment layers than traditional equipment. What they found challenged everything they thought they knew about the timeline of human civilization in that region. About 300 feet below the current sea level, buried under centuries of sediment, they discovered what appeared to be the remains of a structured settlement. Stone foundations arranged in rectangular patterns, what looked like ancient roadways, and most remarkably, evidence of sophisticated drainage systems that would have required advanced engineering knowledge to construct. But here's the kicker. The dating analysis suggests these structures were built when that area was still dry land, before rising sea levels at the end of the last ice age flooded the region. We're talking about a time period between 10,000 and 12,000 years ago, when conventional archaeology tells us that humans in that area should have been living in small hunter-gatherer groups, not building permanent settlements with complex infrastructure. The Black Sea discovery shares some remarkable similarities with the Spanish site. Both show evidence of geometric planning, both appear to incorporate water management systems, and both date to roughly the same time period, the end of the last ice age. Now, this is where things get really mind-bending, because it's not just two sites. As word of these discoveries has spread through the archaeological community, researchers have started re-examining sonar data from underwater surveys conducted over the past decade, and they're finding similar anomalies in locations around the world. Off the coast of Japan, there's the Yonaguni Monument, underwater rock formations that some researchers believe show evidence of human modification. In the Mediterranean, there are submerged structures near Malta that appear far too sophisticated for their supposed age. Near the Bahamas, there are underwater stone formations that have been dubbed the Bimini Road, though their origin remains hotly debated. Individually, each of these sites can be explained away or dismissed as natural formations that happen to look artificial. But when you start looking at them collectively, a pattern emerges that's harder to ignore. What if the end of the last ice age didn't just change the geography of our planet? What if it erased entire civilizations that we're only now beginning to rediscover? To understand why this possibility is so revolutionary, we need to talk about what actually happened during the end of the last ice age. Because the picture that's emerging from climate science is far more dramatic and catastrophic than most people realize. About 12,800 years ago, the Earth's climate underwent a sudden and dramatic shift. Global temperatures plummeted in what scientists call the Younger Dryas period, essentially a mini ice age that lasted for over 1,000 years. But then, around 11,700 years ago, the cold period ended just as abruptly as it had begun. The transition back to warmer temperatures happened incredibly quickly in geological terms. We're talking about massive climate shifts occurring over just a few decades. As the ice sheets melted, sea levels rose by hundreds of feet, flooding vast areas of coastline around the world. But it wasn't just a gradual rise in sea levels. Recent research suggests that the melting was accompanied by massive flooding events, what geologists call glacial lake outburst floods, or Jokull-Laups. When ice dams holding back enormous glacial lakes suddenly failed, the resulting floods would have been biblical in scale, capable of reshaping entire landscapes in a matter of days. Now, here's the crucial point. If advanced civilizations existed during the Ice Age, where would they have built their cities? The answer is obvious. Along coastlines and in river valleys, exactly where the most fertile land and the best trade routes would have been located. And those are precisely the areas that would have been completely inundated when the Ice Age ended. Dr. Lewis Dartnell, an astrobiology professor at the University of Westminster who studies how civilizations respond to catastrophic events, puts it this way. If we imagine an advanced civilization existing 12,000 years ago, we have to remember that their world would have looked completely different from ours. Sea levels were 400 feet lower than they are today. What we now think of as the continental shelf would have been dry land, and that's where the most favorable conditions for civilization would have existed. He continues, when the Ice Age ended, it wasn't just that sea levels rose gradually over thousands of years. There were catastrophic flooding events that could have wiped entire civilizations off the map in a matter of decades. And the evidence of those civilizations would now be sitting on the ocean floor under hundreds of feet of water and thousands of years of sediment. This is why the recent underwater discoveries are so significant. For the first time in human history, we have the technology to systematically search these submerged areas and see what might be down there. But there's another piece of the puzzle that makes this even more intriguing. As researchers have been analyzing the sonar data from these underwater sites, they've noticed something unexpected. Many of these structures appear to incorporate sophisticated understanding of hydraulic engineering. The Spanish site, for instance, shows evidence of channels and waterways that appear to be designed to manage water flow. The Turkish site has what looks like an elaborate drainage system. Even some of the more controversial sites, like Yonaguni, show features that could be interpreted as water management infrastructure. This is significant because advanced hydraulic engineering is one of the hallmarks of sophisticated civilization. The ability to control and direct water flow requires not just practical engineering skills, but also advanced mathematical understanding and long-term planning capabilities. And here's where it gets really interesting. Plato's description of Atlantis placed enormous emphasis on the Atlanteans' mastery of water management. He described elaborate systems of canals, harbors, and waterways that allowed them to control both fresh and salt water throughout their island civilization. Dr. Sarah Chen, a hydraulic engineer at MIT who specializes in ancient water management systems, has been studying the sonar data from the Spanish site. Her preliminary analysis suggests that if these structures are indeed artificial, they represent a level of hydraulic sophistication that rivals some of the greatest achievements of known ancient civilizations. What we're seeing in this data, Dr. Chen explains, are what appear to be integrated water management systems designed to work on a massive scale. If these are real, they would represent some of the most advanced hydraulic engineering we've ever found from the ancient world. But she's also careful to emphasize the limitations of what we can determine from sonar data alone. We're essentially looking at shadows and echoes from the ocean floor. Until we can get down there with cameras and take physical samples, we're making educated guesses about what we're actually seeing. And that's exactly what's happening next. In the coming months, multiple research teams are planning deep-sea expeditions to these sites. Advanced submersibles equipped with high-definition cameras, robotic arms for sample collection, and ground-penetrating radar will be deployed to get the first close-up look at these mysterious structures. The Spanish site will be the first to be physically explored. Dr. Santos has secured funding for a 6-week expedition using the research vessel Atlantis, a name that wasn't chosen for its symbolic value, but because it's one of the few ships equipped with the deep-sea technology needed for this kind of exploration. The expedition will use a remotely operated vehicle called Jason, which can dive to depths of over 21,000 feet and work on the ocean floor for up to 20 hours at a time. Jason is equipped with high-definition cameras, powerful lights, and robotic arms that can collect samples and perform delicate operations on the seafloor. But perhaps most importantly, Jason carries ground-penetrating radar that can see through sediment layers to create detailed three-dimensional maps of buried structures. This technology will allow the team to see not just what's visible on the seafloor surface, but what lies beneath the thousands of years of accumulated sediment. The plan is to start with the largest circular formations identified in the sonar data and work systematically through the site, mapping and documenting everything they find. If the structures do appear to be artificial, the team will collect samples of the construction materials for dating and compositional analysis. They'll also be looking for artifacts, any objects that might provide clues about who built these structures and when. Even something as simple as pottery fragments or tool marks on stone could provide crucial evidence about the civilization that created them. But there's something else the team will be looking for. Something that could provide the most definitive evidence of all, signs of the catastrophic event that supposedly destroyed this civilization. According to Plato, Atlantis was destroyed in a single day and night by earthquakes and floods. If that account is based on real events, there should be geological evidence of such a catastrophe. The research team will be looking for signs of sudden burial, evidence of seismic activity, or layers of sediment that indicate rapid deposition, the kind that would result from a massive flooding event. Dr. James Kennett, a geologist from UC Santa Barbara who specializes in studying ancient catastrophes, explains what they might expect to find. If a coastal civilization was destroyed by the kind of catastrophic flooding that occurred at the end of the Ice Age, we would expect to see very specific geological signatures, layers of sediment deposited rapidly, evidence of massive water flow, possibly even impact materials if the flooding was triggered by a cosmic event. The cosmic impact theory is one of the more controversial aspects of this research. Some scientists believe that the sudden climate changes at the end of the Ice Age might have been triggered by impacts from comets or asteroids. While this theory is still debated, there is growing evidence of impact materials in sediment layers dating to around 12,800 years ago. If the Atlantis legend is based on real events, and if those events were connected to cosmic impacts, then the underwater structures might contain evidence of one of the most significant catastrophes in human history. But even without cosmic impacts, the end of the Ice Age was catastrophic enough. The geological evidence shows that sea levels rose rapidly and dramatically, accompanied by massive flooding events that would have been devastating to any coastal civilizations. The question is, were their coastal civilizations advanced enough to leave behind the kind of sophisticated structures that we're now finding on the ocean floor? For decades, the answer from mainstream archaeology has been a definitive no. The conventional timeline of human civilization places the first complex societies at around 6,000 years ago, with the first cities appearing around 5,500 years ago in Mesopotamia. But that timeline has been based primarily on archaeological evidence found on dry land. If advanced civilizations existed primarily in coastal areas that are now underwater, then we've been looking in the wrong places for evidence of early human sophistication. The underwater discoveries are forcing archaeologists to reconsider some fundamental assumptions about the development of human civilization. Maybe the story of human progress wasn't as linear as we thought. Maybe there were civilizations that rose and fell long before the ones we know about from recorded history. And maybe some of those lost civilizations were advanced enough to inspire the legends and myths that have been passed down through thousands of years of human storytelling. The legend of Atlantis might be the most famous of these stories, but it's far from the only one. Cultures around the world have stories of great floods, lost civilizations, and golden ages that ended in catastrophe. The Hindu Puranas speak of cycles of creation and destruction spanning vast periods of time. Aboriginal Australian cultures have oral traditions describing the flooding of vast areas of land. Native American tribes have stories of great floods that reshaped the world. For generations, these stories have been dismissed as mythology, symbolic tales, rather than historical accounts. But what if at least some of them preserve memories of real events? What if they're the last traces of civilizations that were lost when the Ice Age ended and the seas rose? The technology that's allowing us to explore the deep ocean is also revealing just how much of human history might be hidden beneath the waves. Current estimates suggest that over 3 million shipwrecks lie on the ocean floor, representing thousands of years of human maritime activity. But shipwrecks are just the beginning. If coastal civilizations existed during the Ice Age, their ruins would be scattered across the continental shelves of every continent. We're only just beginning to systematically search these areas, and already we're finding structures that challenge our understanding of ancient human capabilities. As the technology continues to improve and more underwater surveys are conducted, who knows what other mysteries we might uncover? The Spanish site might be just the first of many discoveries that force us to rewrite the story of human civilization. And if that's the case, then we're living through one of the most exciting periods in archaeological history, a time when technology is finally allowing us to recover lost chapters of our own past. But we're getting ahead of ourselves. Right now, all we have are sonar images and scientific speculation. The real test will come when the submersibles descend to the ocean floor and we get our first close-up look at these mysterious structures. Will they turn out to be natural formations that happen to look artificial? Will they be the remains of some unknown ancient civilization? Or could they actually be the ruins of the legendary Atlantis itself? Within the next year, we should have some answers. And those answers might change everything we thought we knew about the history of human civilization on Earth. The expedition to the Spanish site is scheduled to begin in just 6 months, but the team isn't waiting to start analyzing what they've already found. Dr. Santos and her colleagues have been using artificial intelligence to process the massive amounts of sonar data they've collected, and the results are revealing details that human analysts would have missed. The AI system, originally developed for analyzing satellite imagery of Mars, has been trained to identify geometric patterns and artificial structures in underwater environments. When the Spanish team fed their sonar data into the system, it immediately flagged dozens of features that hadn't been noticed in the initial analysis. Most intriguingly, the AI identified what appears to be a hierarchical structure to the site. The largest circular formations seem to be positioned at regular intervals, with smaller circular and rectangular structures arranged around them in a pattern that suggests deliberate urban planning. It's the kind of organization you'd expect to see in a city, not in natural geological formations. But here's where things get really fascinating. The AI also detected subtle variations in the seafloor that suggest the presence of roads or pathways connecting these structures. These linear features are barely visible in the original sonar data, but the AI's pattern recognition capabilities picked up on slight differences in sediment density and composition that indicate something solid lies beneath. Dr. Elena Vasquez, a specialist in archaeological remote sensing who's been working with the AI analysis, describes what they're seeing. Imagine looking at a city from space, but the city is covered by a thick layer of snow that's been accumulating for thousands of years. You can't see the buildings directly, but you can see subtle variations in how the snow has settled that tell you something is underneath. The AI analysis has also revealed something unexpected about the scale of the site. The original sonar surveys covered about 50 square kilometers, but the pattern recognition suggests that the structures extend well beyond that area. Based on the spacing and organization of the features they've mapped so far, the AI estimates that the complete site could cover an area of over 200 square kilometers. If those estimates are correct, we're not talking about a small settlement or even a single city. We're talking about something closer to a city-state or small kingdom, exactly the kind of scale that Plato described for Atlantis. But size isn't the only factor that's got researchers excited. The AI has also identified features that suggest a level of technological sophistication that would be remarkable for any ancient civilization, let alone one from 12,000 years ago. Remember those water management systems we talked about earlier? The AI analysis has revealed that they're even more complex than initially thought. The channels and waterways don't just connect the circular structures. They form an integrated network that appears designed to control water flow across the entire site. Dr. Michael Hartman, a hydraulic engineer who specializes in ancient water systems, has been studying the AI-generated maps. His analysis suggests that the waterway network would have been capable of managing both freshwater and saltwater, directing flow to different areas of the site based on need. Well, what we're looking at, Dr. Hartman explains, is a water management system that rivals anything built by the Romans or the ancient Egyptians. The level of planning and engineering required to create something like this would indicate a civilization with advanced mathematical knowledge and sophisticated construction capabilities. But there's another aspect of the AI analysis that's even more intriguing. The system has identified what appear to be harbor structures, areas where the waterways connect to what would have been the ancient coastline. These aren't just simple docks or piers. They appear to be elaborate port facilities, with multiple channels, protected anchorages, and what might be ancient lighthouse foundations. If this interpretation is correct, it would mean that this civilization wasn't just advanced in terms of urban planning and hydraulic engineering, they were also sophisticated maritime traders. And that opens up some fascinating possibilities about their connections to other ancient cultures. Dr. Robert Chen, a specialist in ancient maritime trade networks, has been studying the harbour structures identified by the AI. His preliminary analysis suggests that the design and scale of these facilities would have been capable of handling large vessels and high volumes of trade. If these really are ancient harbour structures, Dr. Chen says, then we're looking at evidence of a maritime civilization that could have had trading relationships across the Atlantic and Mediterranean. The implications for our understanding of ancient global connections would be enormous. This possibility becomes even more intriguing when you consider some of the anomalies that archaeologists have found at ancient sites around the world. There are Egyptian artifacts that contain traces of nicotine and cocaine, plants that supposedly didn't exist in the Old World until after Columbus. There are ancient maps that seem to show coastlines with remarkable accuracy, including areas that were supposedly unknown to ancient civilizations. Could these anomalies be evidence of ancient transoceanic contact? Could there have been a maritime civilization advanced enough to maintain trade networks spanning thousands of miles of open ocean? The mainstream archaeological community has traditionally been skeptical of theories about ancient transoceanic contact. The conventional wisdom has been that ancient peoples lacked the navigational skills and shipbuilding technology necessary for long-distance ocean voyages. But that conventional wisdom is increasingly being challenged. We now know that ancient peoples were far better navigators than previously thought. Polynesian cultures regularly crossed thousands of miles of open ocean using traditional navigation techniques. Viking explorers reached North America 500 years before Columbus. Even supposedly primitive cultures like the ancient Egyptians were capable of remarkable maritime achievements. The discovery of what appears to be an advanced maritime civilization from 12,000 years ago would push these capabilities back even further. It would suggest that humans developed sophisticated ocean-going capabilities much earlier than anyone previously imagined, but we're still dealing with interpretations of sonar data. The real test will come when the submersibles actually reach the seafloor and we can see these structures up close. And that's where the story takes another fascinating turn. The deep sea expedition isn't just about confirming whether these structures are artificial. The team is also hoping to solve one of the biggest mysteries about the site. What happened to the people who built it? If this really was an ancient civilization that was destroyed by catastrophic flooding, there should be evidence of that destruction preserved in the geological record. But there might also be something else. Something that could provide direct evidence of the people themselves. Dr. Lisa Morgan, a bioarchaeologist who specializes in ancient DNA recovery, will be part of the expedition team. Her job will be to look for any organic materials that might have been preserved in the deep sea environment. The deep ocean is actually an excellent preservation environment, Dr. Morgan explains. The cold temperatures, the lack of oxygen, and the protective sediment layers can preserve organic materials for thousands of years. If this site really is as old as we think it is, there's a chance we might find preserved organic materials, wood, textiles, maybe even human remains. The possibility of finding ancient DNA from this site is particularly exciting because it could provide direct evidence of who these people were and where they came from. Modern genetic analysis techniques can extract DNA from incredibly small samples and use it to trace population movements and relationships across thousands of years. If the expedition does find organic materials, and if they can extract DNA from them, it could revolutionize our understanding of ancient human migration patterns. We might discover that there were sophisticated human populations in areas we never suspected, or that ancient peoples were more mobile and interconnected than we previously imagined. But DNA analysis could also help resolve one of the most contentious questions about this discovery, whether it has any connection to the Atlantis described by Plato. Remember, Plato claimed that the Atlanteans were descendants of the god Poseidon and had spread their influence across much of Europe and Africa before being defeated by ancient Athens. If this sounds like mythology, that's because it probably is, at least in part. But what if Plato was trying to preserve a genuine historical memory using the storytelling conventions of his time? Ancient historians often presented historical accounts in mythological terms, especially when dealing with very ancient events that had been passed down through oral tradition. If the Spanish site really is connected to the Atlantis legend, then DNA analysis of any human remains found there could potentially be compared to ancient DNA from other archaeological sites around the Mediterranean and Atlantic. This could reveal whether there really were ancient population movements that match Plato's description of Atlantean expansion. Dr. Johannes Krause, a pioneer in ancient DNA research from the Max Planck Institute, has expressed interest in analyzing any organic materials recovered from the site. His team has successfully extracted DNA from human remains over 40,000 years old. So the potential 12,000-year age of this site wouldn't be a technical barrier. If we can recover DNA from this site, Dr. Krauss says, we could potentially trace the genetic lineage of these people and see how they relate to other ancient populations. We might even be able to determine whether they had genetic markers associated with particular skills or adaptations that could explain their apparent technological sophistication. The genetic analysis could also help resolve another mystery about ancient civilizations: why some groups seem to have developed advanced technologies much earlier than others. Recent genetic research has shown that certain populations carry genetic variants associated with enhanced cognitive abilities or particular skills. If the people who built these underwater structures had unique genetic characteristics, it might help explain their apparent technological achievements. But we're getting into highly speculative territory here. The truth is, we won't know what we're dealing with until the submersibles actually reach the seafloor and start collecting data and samples. The expedition itself will be a technological marvel. The research vessel Atlantis will serve as the base of operations, positioned directly above the most promising areas identified by the sonar surveys. From there, the remotely operated vehicle Jason will be deployed to conduct detailed surveys of the structures. Jason is equipped with some of the most advanced underwater exploration technology ever built. Its high-definition cameras can capture images in the complete darkness of the deep sea using powerful LED lighting systems. Its robotic arms can manipulate objects with surgical precision, allowing it to collect samples or clear away sediment to reveal hidden features. But perhaps most importantly, Jason carries ground-penetrating radar that can see through the sediment layers that have accumulated over thousands of years. This technology will allow the team to create detailed, three-dimensional maps of the buried structures without having to excavate them, a process that would be extremely difficult and expensive at such depths. The expedition is planned to last 6 weeks, with Jason conducting daily dives to different areas of the site. Each dive will focus on specific structures identified in the sonar data, starting with the largest and most clearly defined features and working systematically through the site. The team has developed a detailed protocol for documenting everything they find. Each structure will be photographed from multiple angles, measured precisely, and sampled if possible. Any artifacts or unusual features will be documented extensively before samples are collected for later analysis. But there's another aspect of this expedition that makes it unique in the history of underwater archaeology. For the first time, the entire process will be live-streamed to researchers around the world, allowing experts in different fields to observe and provide input in real time. Dr. Santos explains the reasoning behind this approach. This discovery is too important to be limited to a single research team. By making our exploration process transparent and collaborative, we can ensure that we're not missing anything important and that the global scientific community can participate in interpreting what we find. The live streaming will also allow the public to witness this historic exploration as it happens. Imagine watching in real time as cameras reveal the first close-up images of structures that have been hidden beneath the ocean for over 10,000 years. It could be one of the most significant moments in archaeological history, broadcast live to audiences around the world. But what if the expedition reveals something that challenges our most fundamental assumptions about human history? What if these structures are not just artificial, but so sophisticated that they force us to completely reconsider the timeline of human technological development? There's precedent for this kind of paradigm shift. The discovery of Göbekli Tepe in Turkey revolutionized our understanding of prehistoric human capabilities. This massive stone complex, with its intricately carved pillars and sophisticated construction, was built over 11,000 years ago by people who were supposedly simple hunter-gatherers. Göbekli Tepe forced archaeologists to admit that our ancestors were capable of much more sophisticated achievements much earlier than anyone had imagined. The discovery fundamentally changed how we think about the development of human civilization and the relationship between technological advancement and social organization. The underwater structures off the Spanish coast could represent an even bigger paradigm shift. If they really are as old and sophisticated as the preliminary evidence suggests, they could force us to completely rewrite the story of human technological development. Dr. Klaus Schmidt, the archaeologist who excavated Göbekli Tepe, once said that his discovery was like finding a Porsche in the garage of a caveman. The Spanish underwater site could be the equivalent of finding an entire advanced civilization in what we thought was prehistory. But there's another possibility that's even more intriguing. What if this isn't an isolated discovery? What if advanced underwater structures are actually common, but we've just never had the technology to find them before? As word of the Spanish discovery has spread through the archaeological community, researchers have been taking another look at sonar data from underwater surveys conducted over the past few decades, and they're finding anomalies that were previously dismissed or overlooked. Off the coast of India, there are sonar images of what appear to be geometric structures beneath the Bay of Bengal. Near the Caribbean islands, there are underwater formations that show signs of artificial modification. Even in the Arctic Ocean, there are sonar anomalies that some researchers now think might be worth investigating. Dr. Sarah Parkak, a space archaeologist who uses satellite imagery to identify ancient sites, believes we may be on the verge of a revolution in underwater archaeology. We're developing the tools to systematically search the ocean floor for the first time in human history, she says. And what we're finding suggests that there's much more down there than anyone imagined. The implications go far beyond archaeology. If the ocean floors contain extensive remains of ancient civilizations, it could provide crucial information about how human societies respond to catastrophic climate change. The end of the last ice age was one of the most dramatic climate shifts in Earth's history, and the civilizations that existed then had to adapt or perish. By studying how ancient peoples dealt with rising sea levels, massive flooding, and dramatic environmental changes, we might gain insights that are relevant to our own situation as we face the challenges of modern climate change. Dr. Benjamin Horton, a sea level researcher at Rutgers University, has been studying the rate of sea level rise at the end of the last ice age. His research shows that in some areas, sea levels rose by several meters per century, a rate that would have been devastating to coastal civilizations. If advanced civilizations existed during the ice age, Dr. Horton explains, they would have faced the challenge of adapting to rapid and dramatic environmental change. The strategies they used to survive, or the reasons they failed to survive, could provide valuable lessons for modern society. This perspective adds another layer of urgency to the underwater exploration. We're not just looking for ancient ruins or trying to solve historical mysteries. We're potentially uncovering information that could be crucial for humanity's future survival. The Spanish expedition is just the beginning. If the structures do prove to be artificial, it will likely trigger a wave of similar expeditions to underwater sites around the world. We could be entering an era of discovery that reveals an entirely hidden chapter of human history. But even if the expedition reveals that these structures are natural formations that happen to look artificial, the technology being developed for this exploration will revolutionize our ability to study the ocean floor. Future discoveries are inevitable as we continue to develop better tools for deep-sea exploration. The next few months will be crucial. As the expedition team makes final preparations for their deep-sea dive, the anticipation in the archaeological community is reaching fever pitch. Everyone knows that what they find could change everything we thought we knew about our past. And somewhere beneath 2 miles of crushing ocean water, the answers are waiting. The timeline for this historic expedition is moving faster than anyone expected. What was supposed to be a carefully planned 6-month preparation period has been compressed to just 3 months, and there's a reason for that urgency that goes beyond scientific excitement. In late September 2024, something happened that changed everything. A commercial fishing vessel operating about 200 miles northwest of the Spanish site made an accidental discovery that sent shockwaves through the research community. While dragging nets at unusual depths due to equipment malfunction, they snagged something that shouldn't have been there. What they pulled up weren't fish. They were fragments of worked stone, pieces that showed clear evidence of tool marks, geometric shaping, and what appeared to be decorative carving. The stone itself was unlike anything found naturally in that region of the Atlantic. Preliminary analysis suggests it's a type of volcanic rock that would have had to be transported from hundreds of miles away. But here's what made this discovery absolutely electrifying. The fishing vessel's GPS coordinates placed them directly over what the sonar data had identified as one of the linear corridor structures extending from the main Spanish site. Dr. Santos received the call about the fishing vessel discovery at 2 a.m. on a Tuesday morning. Within hours, she had assembled an emergency team and was on a boat heading to the coordinates provided by the fishing captain. What they found when they arrived changed the entire scope of the investigation. Using portable sonar equipment, they were able to confirm that the fishing nets had indeed snagged on structures that extended much further from the main site than anyone had realized. The underwater complex wasn't confined to the 50 square kilometers they had originally mapped. It was enormous, possibly covering an area larger than Manhattan. More importantly, the stone fragments provided the first physical evidence that these weren't natural formations. The tool marks were unmistakable, and the decorative elements showed a level of artistic sophistication that would have required not just advanced tools, but a complex cultural system capable of supporting specialized craftsmen. Dr. Patricia Alvarez, a specialist in ancient stoneworking techniques from the University of Barcelona, was brought in to analyze the fragments. Her initial assessment was stunning. These stones show evidence of multiple different tool types being used in their creation. We're seeing marks from chisels, abrading stones, and what might even be early metal tools. The level of craftsmanship is comparable to what we see in the finest ancient Mediterranean stonework. But there was something else about the stone fragments that made them even more significant. Embedded within the rock matrix were tiny particles of a metal that shouldn't exist, at least not in that location and not in that time period. Dr. Michael Rodriguez, a materials scientist specializing in ancient metallurgy, ran the metal particles through mass spectrometry analysis. The results left him staring at his computer screen in disbelief. The particles contained traces of tin and copper in precise ratios that indicated intentional alloying, the creation of bronze. Bronze working is considered one of the hallmarks of advanced ancient civilizations. It requires not just the knowledge of how to extract metals from ore, but also the understanding of how to combine them in specific proportions to create alloys with desired properties. Most importantly, it requires sustained high-temperature furnaces and sophisticated metallurgical knowledge. The conventional timeline places the beginning of the Bronze Age at around 3300 BCE in the Near East, spreading to Europe by about 2500 BCE. But if these metal particles really are from the underwater structures, they would push bronze working back by thousands of years and place it in a location where it supposedly never existed. Dr. Rodriguez is being extremely cautious about his findings. We need to rule out contamination, modern pollution, and any other possible explanation before we can say definitively that these metal traces are ancient, he explains. But if they are genuine, they would represent some of the earliest evidence of intentional metal alloying ever discovered. The discovery of the stone fragments accelerated the expedition timeline, but it also created new challenges. Word of the find began to leak out through the scientific community, and suddenly the Spanish site wasn't just of interest to archaeologists. It was attracting attention from treasure hunters, amateur explorers, and commercial salvage companies. The Spanish government moved quickly to protect the site, declaring it a protected archaeological zone and establishing a 50-mile exclusion area around the coordinates. Naval vessels now patrol the area to prevent unauthorized access, and the expedition team has been given exclusive research rights for the next 5 years. But the protection measures came almost too late. Satellite imagery from the weeks following the fishing vessel discovery shows several unidentified vessels in the area, including at least 2 that appeared to be equipped with deep-sea exploration equipment. By the time the naval patrols were established, unknown parties had already spent considerable time over the site. Dr. Santos is concerned about what damage might have been done. Unauthorized salvage operations could have destroyed irreplaceable archaeological evidence, she says. Every artifact removed from its original context is a piece of the story we'll never be able to recover. The threat of treasure hunters and commercial salvage operations is a serious problem in underwater archaeology. Unlike land-based sites, which can be physically protected and monitored, underwater sites are vulnerable to anyone with the right equipment and the wrong intentions. The most famous example is the ongoing destruction of ancient shipwrecks in the Mediterranean by commercial salvage companies. These operations use powerful suction equipment that strips away centuries of archaeological context in hours, recovering valuable artifacts while destroying the scientific information that makes them historically significant. The Spanish site faces similar threats, but the scale of potential damage is much larger. If these really are the remains of an ancient civilization, they represent an irreplaceable record of human achievement that could be lost forever to commercial exploitation. The urgency created by these threats has led to some remarkable international cooperation. Research institutions from 12 different countries have committed resources to the expedition, including specialized equipment, expert personnel, and funding. It's one of the largest collaborative underwater archaeological projects ever attempted. The technological resources being brought to bear on this investigation are staggering. In addition to the research vessel Atlantis and the ROV Jason, the expedition will include a deep-sea drilling platform capable of taking core samples from beneath the structures to determine their age and construction methods, side-scan sonar arrays that can map the site in unprecedented detail, revealing features as small as individual stones, magnetometers that can detect buried metal objects and map subsurface structures, chemical analysis equipment that can determine the composition and origin of materials in real time, and perhaps most importantly, a team of specialists representing every relevant field of study: marine geology, underwater archaeology, ancient metallurgy, hydraulic engineering, genetic analysis, and even experts in ancient languages and writing systems. Dr. Elena Vasquez, who's been coordinating the international team, describes the scope of the collaboration. We've assembled what amounts to a floating university focused on a single archaeological site. The level of expertise we're bringing to this investigation is unlike anything that's been attempted before in underwater archaeology. But all this preparation and collaboration hinges on one crucial question. What will they actually find when they get down there? The stone fragments from the fishing vessel provide tantalizing clues, but they're just pieces of a much larger puzzle. The real test will come when the cameras and instruments reach the seafloor and reveal these structures in full detail for the first time. The expedition team has developed multiple scenarios for what they might encounter, ranging from disappointing natural formations to world-changing archaeological discoveries. But there's one possibility that everyone is thinking about, but nobody wants to say out loud. What if they find something that's so far outside our current understanding of ancient civilizations that it challenges not just archaeological timelines, but our fundamental assumptions about human technological development? Dr. Graham Hancock, a controversial researcher who has long argued for the existence of lost advanced civilizations, has been following the Spanish discovery closely. While many mainstream archaeologists are skeptical of Hancock's theories, even his critics admit that the underwater structures raise questions that are difficult to answer within conventional frameworks. What we're potentially looking at, Hancock observes, is evidence that human civilization is much older and much more sophisticated than we've been taught to believe. If these structures are what they appear to be, they could force us to completely reconsider the story of human development. The mainstream archaeological community remains cautious. Dr. Sarah Parkak, whose satellite archaeology work has revolutionized the field, emphasizes the importance of following rigorous scientific protocols. Extraordinary claims require extraordinary evidence. We need to approach this investigation with the highest possible scientific standards and be prepared to accept whatever the evidence tells us, even if it challenges our preconceptions. But even the most conservative researchers admit that the preliminary evidence is compelling. Dr. Zahi Hawass, the renowned Egyptologist who has been skeptical of many underwater archaeological claims, has expressed cautious interest in the Spanish site. The sonar data is intriguing, Dr. Hawass says, and the stone fragments provide physical evidence that demands investigation. We must be careful not to jump to conclusions, but we also cannot ignore evidence simply because it doesn't fit our current understanding. The expedition is also taking place against the backdrop of other recent discoveries that have challenged conventional archaeological timelines. The site of Karahan Tepe in Turkey, even older than Göbekli Tepe, has revealed increasingly sophisticated prehistoric monuments. In Indonesia, the Gunung Padang site shows evidence of human construction dating back over 20,000 years. Each of these discoveries has forced archaeologists to push back the timeline of human technological sophistication. The Spanish underwater site could represent the next major step in this process of reconsidering our past. But there's another aspect of this investigation that goes beyond archaeology and touches on some of the deepest questions about human nature and potential. If these structures really are the remains of a sophisticated ancient civilization, what happened to the knowledge and capabilities that created them? This question becomes even more poignant when you consider the timeline. If the structures are 12,000 years old, they were created just as the last ice age was ending and global sea levels were rising dramatically. The people who built them would have faced some of the most challenging environmental conditions in human history. Dr. Brian Fagan, an archaeologist who specializes in how ancient peoples adapted to climate change, sees the Spanish site as potentially providing crucial insights into human resilience and adaptability. If this really is evidence of an advanced civilization that existed during the end of the Ice Age, Dr. Fagan explains, then we're looking at people who had to deal with the most dramatic climate changes in human history. Understanding how they adapted or failed to adapt could provide valuable lessons for our own situation. The parallels to our current climate situation are striking. Like the ancient peoples who may have built these structures, we're facing rapid environmental changes, rising sea levels, and the need to adapt our civilizations to new conditions. Dr. Michael Mann, a climate scientist at Penn State who studies both ancient and modern climate change, has been following the Spanish investigation with great interest. The end of the last ice age was characterized by rapid and dramatic changes in sea level, temperature, and weather patterns, Dr. Mann explains. If sophisticated civilizations existed during that time, studying how they responded to these changes could provide insights that are relevant to our current climate crisis. This perspective adds yet another layer of significance to the upcoming expedition. The team isn't just looking for archaeological artifacts or trying to solve historical mysteries. They're potentially uncovering information about human adaptability and resilience that could be crucial for our species' future. The expedition timeline has been compressed, but the preparation has been intense. The research vessel Atlantis has been equipped with the most advanced deep-sea exploration technology available. The ROV Jason has been upgraded with new cameras, sampling equipment, and analytical instruments specifically designed for this mission. The human element of the expedition is equally impressive. The team includes some of the world's leading experts in underwater archaeology, ancient engineering, metallurgy, and genetic analysis. They've been training together for months, preparing for every possible scenario they might encounter on the seafloor. Dr. Santos, who will serve as the expedition leader, describes the team's mindset. We're approaching this investigation with a combination of scientific rigor and open-minded curiosity. We're prepared to find natural formations that happen to look artificial, but we're also prepared to find evidence that could change our understanding of human history. The live streaming component of the expedition has generated unprecedented public interest. Over 200,000 people have already signed up to receive notifications when the live feeds begin. Educational institutions around the world are planning to incorporate the expedition into their curricula, giving students the opportunity to witness potential history-making discoveries in real time. But there's also pressure that comes with this level of public attention. The team knows that millions of people will be watching their every move, analysing their interpretations, and forming their own conclusions about what they find. Dr. James Cameron, the filmmaker and deep-sea explorer who has made numerous groundbreaking underwater discoveries, has been consulting with the expedition team on the challenges of conducting scientific research under intense public scrutiny. The key is to maintain scientific objectivity while also communicating effectively with the public, Cameron advises. People are fascinated by the possibility of discovering lost civilizations, but it's important to help them understand the scientific process and the difference between evidence and speculation. The expedition is scheduled to begin in just 8 weeks, and the anticipation is building to a fever pitch. Every day brings new developments, new questions, and new possibilities. Preliminary analysis of additional stone fragments recovered by follow-up fishing operations has revealed even more intriguing details. Some of the stones show evidence of precise geometric shaping that would have required sophisticated measuring tools. Others display carved symbols that don't match any known ancient writing systems. Dr. Antonio Rivera, an expert in ancient scripts and symbols from the University of Madrid, has been studying photographs of these carvings. His initial assessment is that they appear to represent a systematic symbolic system, possibly a form of early writing or numerical notation. The symbols show clear patterns and repetitions that suggest they're not random decorations, Dr. Rivera explains. They appear to be organized according to some kind of logical system, which would indicate a level of intellectual sophistication that's remarkable for any ancient culture. If the symbols do represent an early writing system, it would be one of the oldest ever discovered. Most known ancient writing systems don't appear until around 3200 BCE in Mesopotamia. A writing system from 12,000 years ago would push back the development of human symbolic communication by thousands of years. But Dr. Rivera is careful to emphasize the preliminary nature of his analysis. We're working from photographs of stone fragments pulled up by fishing nets, he says. We need to see these symbols in their original context, with proper lighting and measurement tools, before we can make any definitive statements about what they represent. The discovery of possible symbolic systems adds another dimension to the upcoming expedition. The team will now be looking not just for evidence of advanced engineering and construction techniques, but also for signs of literacy, mathematical knowledge, and symbolic thinking. These cognitive capabilities are considered hallmarks of advanced civilization. The ability to create and manipulate abstract symbols is what allows human societies to develop complex knowledge systems, maintain cultural continuity across generations, and coordinate large-scale projects. If the underwater structures really do show evidence of these capabilities from 12,000 years ago, it would suggest that human cognitive development reached sophisticated levels much earlier than previously thought. Dr. Merlin Donald, a cognitive scientist who studies the evolution of human consciousness and culture, has been following the Spanish discoveries with fascination. The development of symbolic systems represents a crucial turning point in human cognitive evolution, Dr. Donald explains. If we're looking at evidence of sophisticated symbolic thinking from 12,000 years ago, it could fundamentally change our understanding of how human consciousness and culture developed. As the expedition approaches, the questions continue to multiply. Each new piece of evidence raises possibilities that seemed unthinkable just months ago. The stone fragments, the metal traces, the geometric patterns, the possible symbolic systems. Taken together, they paint a picture of ancient human capabilities that challenges everything we thought we knew about our past. But questions and speculation can only take us so far. The answers lie waiting on the ocean floor, beneath 2 miles of crushing water and thousands of years of accumulated sediment. In just 8 weeks, we'll finally have the technology and the opportunity to reach down into that ancient darkness and see what's really there. The expedition team is ready. The equipment has been tested and retested. The protocols have been established. The world is watching. Whatever they find down there, it's going to change how we think about human civilization, human potential, and our place in the long story of life on Earth. The countdown has begun, but while the world waits for those answers, Something else has been happening in the scientific community that's adding even more intrigue to this story. Because the Spanish site isn't just challenging our understanding of ancient civilizations, it's forcing researchers to confront uncomfortable questions about what else we might have missed. Dr. Rebecca Chen, a marine geologist at Woods Hole Oceanographic Institution, has been conducting a systematic review of sonar data collected from underwater surveys over the past 2 decades. What she's finding is disturbing the comfortable assumptions that have guided underwater archaeology for generations. We've been looking at this data for years, Dr. Chen explains, but we've been filtering it through our preconceptions about what ancient humans were capable of. When you remove those filters and look at the raw data with fresh eyes, anomalies start appearing everywhere. Her team has identified over 40 locations around the world where sonar surveys have detected geometric patterns on the ocean floor that were previously dismissed as natural formations. Most of these sites are at depths that would have been dry land during the Ice Age, and many show the same kinds of organized, systematic layouts that have made the Spanish site so compelling. The implications are staggering. If even a fraction of these sites represent genuine archaeological remains, we're not talking about isolated examples of ancient sophistication. We're talking about evidence of widespread advanced civilizations that existed thousands of years before the dawn of recorded history. Dr. Marcus Webb, a statistical analyst who specializes in pattern recognition, has been working with Dr. Chen's team to develop algorithms that can identify artificial structures in sonar data without human bias. The preliminary results of their analysis are keeping him awake at night. When we run the data through our algorithms, Dr. Webb says, we're seeing patterns that suggest organized construction at sites across every major ocean basin. The statistical probability that all of these are natural formations is essentially 0. But here's where the story takes an even more fascinating turn. As word of these discoveries has spread through the research community, historians and anthropologists have been taking a fresh look at ancient texts and oral traditions that were previously dismissed as mythology. Dr. Jennifer Martinez, a specialist in comparative mythology at Harvard University, has been cataloging flood myths and stories of lost civilizations from cultures around the world. What she's finding suggests that these stories might be more than just symbolic tales. They might be fragmented memories of real historical events. Every major culture on Earth has stories about great floods that destroyed advanced civilizations, Dr. Martinez explains. We've always assumed these were symbolic or metaphorical, but the underwater archaeological evidence is forcing us to consider the possibility that they're based on actual historical memories. The Aboriginal Australians have oral traditions describing vast lands that were swallowed by the sea. Hindu texts speak of cycles of destruction and rebirth spanning enormous periods of time. Native American cultures preserve stories of great floods that reshaped the world. Even the Bible's account of Noah's flood shares remarkable similarities with flood myths from Mesopotamia, Greece, and dozens of other cultures. For generations, scholars explained these similarities as evidence of universal human psychological patterns or shared cultural diffusion. But what if they represent something more literal, collective memories of actual catastrophic events that destroyed real civilizations? Dr. Martinez has been working with linguists and anthropologists to trace these flood myths back to their earliest known forms. What they're finding suggests that many of these stories contain remarkably specific details about geography, technology, and cultural practices that would be difficult to explain as pure invention. Some of these oral traditions contain information about sea levels, coastlines, and even star positions that correspond to conditions that existed thousands of years ago, Dr. Martinez notes. It's as if they're preserving scientific observations alongside the mythological narratives. This possibility becomes even more intriguing when you consider the sophistication of some ancient oral traditions. Australian Aboriginal cultures have maintained accurate oral histories spanning over 40,000 years. Some of their stories contain verifiable information about sea level changes and geographical features that existed tens of thousands of years ago. If oral traditions can preserve accurate information across such vast time spans, then the flood myths found in cultures around the world might indeed represent memories of the catastrophic sea level rise that occurred at the end of the last ice age. Dr. Patrick Nunn, a geographer who studies the relationship between oral traditions and geological events, has been documenting cases where traditional stories have led to genuine scientific discoveries. There are numerous examples of oral traditions accurately preserving information about ancient geological events, Dr. Nunn explains. In some cases, traditional stories have helped scientists locate and understand natural phenomena that occurred thousands of years before written records began. The most famous example involves Aboriginal Australian stories about volcanic eruptions that occurred over 37,000 years ago. These oral traditions preserved not just the fact that eruptions occurred, but specific details about their location, duration, and effects on local populations. When volcanologists investigated the sites mentioned in the stories, they found geological evidence that confirmed the accuracy of the oral accounts. If traditional flood stories are similarly grounded in historical reality, they could provide crucial information about the civilizations that were destroyed when the Ice Age ended. Details about their technology, their social organization, their geographic distribution, and even their ultimate fate might be preserved in myths and legends that have been passed down for hundreds of generations. Dr. Martinez and her team have been using advanced computational linguistics to analyze flood myths from around the world, looking for common elements that might point to shared historical origins. Their preliminary findings suggest that many of these stories share remarkably specific details about the nature and timing of the catastrophic events they describe. We're seeing consistent references to sudden inundation, to the loss of advanced technologies, and to the survival of small groups who preserve knowledge and skills from the destroyed civilizations, Dr. Martinez explains. These aren't the kinds of details you'd expect to see if these were purely mythological accounts. But there's another aspect of these traditional stories that's particularly relevant to the current underwater discoveries. Many flood myths specifically mention that the destroyed civilizations possessed advanced knowledge of water management, navigation, and marine engineering. Plato's account of Atlantis emphasizes the Atlanteans' mastery of hydraulic engineering and their sophisticated understanding of coastal management. Hindu texts describe the lost city of Dwarka as having elaborate harbor systems and underwater foundations. Even Native American flood stories often mention peoples who were skilled at building on and underwater. These consistent references to aquatic engineering capabilities take on new significance in light of the water management systems that have been identified in the sonar data from underwater sites around the world. Dr. Alan Morrison, a hydraulic archaeologist who studies ancient water technologies, has been analyzing these mythological references alongside the engineering evidence from underwater sites. What's striking is how specific these traditional accounts are about hydraulic technologies, Dr. Morrison observes. They're not just saying that ancient peoples lived near water, they're describing sophisticated understanding of water flow, pressure, and containment that would require advanced engineering knowledge. This correlation between mythological accounts and archaeological evidence is forcing researchers to reconsider the relationship between legend and history. Perhaps these ancient stories aren't just symbolic representations of universal human experiences. Perhaps they're fragmented records of actual technological achievements that were lost when their creators disappeared beneath the rising seas. The implications extend far beyond archaeology. If advanced civilizations really did exist during the Ice Age, and if they possessed sophisticated technologies that were subsequently lost, it could explain some of the puzzling discontinuities in the archaeological record. Why did agriculture appear independently in multiple locations around the world at roughly the same time? Why do so many ancient cultures show evidence of advanced astronomical knowledge that would have taken generations to develop? Why do we find evidence of sophisticated mathematical concepts in cultures that supposedly had no contact with each other? Traditional explanations for these patterns rely on independent invention. The idea that human cultures naturally develop similar technologies and knowledge systems when they reach certain levels of complexity. But what if some of these achievements weren't independent inventions, but recovered knowledge from earlier civilizations? Dr. Sandra Hutchinson, an archaeologist who studies technological diffusion in ancient cultures, has been exploring this possibility. Her research suggests that some ancient achievements might represent the rediscovery and adaptation of knowledge that had been preserved from much earlier periods. When you look at certain ancient technologies, Dr. Hutchinson explains, they appear suddenly in the archaeological record without the gradual development you'd expect to see if they were being invented from scratch. It's as if people already knew how to do these things and were just adapting existing knowledge to new circumstances. The most famous example is the sudden appearance of sophisticated mathematical and astronomical knowledge in ancient Mesopotamia. The Babylonians seem to have possessed advanced understanding of planetary motions, eclipse prediction, and mathematical relationships that would have required centuries of careful observation to develop. Yet this knowledge appears in their earliest records without evidence of the gradual development process that should have preceded it. Similar patterns appear in ancient Egypt, where sophisticated architectural and engineering techniques seem to emerge fully formed in the earliest dynastic periods. The precision of pyramid construction, the complexity of irrigation systems, and the mathematical knowledge required for large-scale projects all suggest capabilities that developed much faster than conventional timelines would predict. Dr. Hutchinson's research suggests that these rapid developments might be explained by the preservation and transmission of knowledge from earlier civilizations that were destroyed by the climate catastrophes at the end of the Ice Age. If advanced civilizations existed during the Ice Age, Dr. Hutchinson explains, small groups of survivors might have preserved crucial knowledge that was later used to jumpstart technological development in new locations. This could explain why certain achievements appear so suddenly in the archaeological record. This possibility becomes even more intriguing when you consider the role that catastrophic events play in preserving and transmitting cultural knowledge. When civilizations face existential threats, they often make extraordinary efforts to preserve their most important achievements for future generations. Dr. Michael Chen, a specialist in cultural transmission and memory systems, has studied how societies respond to catastrophic threats. His research shows that when civilizations face destruction, they typically develop specialized methods for preserving and transmitting essential knowledge. Throughout history, societies facing catastrophic collapse have created various systems for ensuring that crucial knowledge survives, Dr. Chen explains. These can include oral traditions, symbolic systems, physical monuments, and even hidden repositories designed to be discovered by future generations. The most famous historical example is the preservation of Greek and Roman knowledge by Islamic scholars during the European Dark Ages. When political upheaval threatened to destroy classical learning, dedicated groups made extraordinary efforts to copy, translate, and preserve essential texts. Much of this knowledge was later rediscovered during the Renaissance and formed the foundation of modern European intellectual development. If similar preservation efforts were made by Ice Age civilizations facing catastrophic sea level rise, the knowledge they saved might have formed the foundation for later achievements that we currently consider independent inventions. The underwater sites being discovered around the world could represent evidence of these preservation efforts. The sophisticated construction techniques, the apparent integration of water management systems, and the geometric precision of the layouts all suggest societies that possessed advanced knowledge and were making efforts to create durable records of their achievements. Dr. Chen has been working with the Spanish expedition team to develop protocols for identifying possible knowledge preservation systems in the underwater structures. If these sites were designed to preserve information for future generations, Dr. Chen explains, they would likely incorporate specific features designed to protect and encode knowledge. We need to be looking not just for evidence of advanced construction techniques, but for signs that these structures were intended to serve as repositories of information. This search for encoded knowledge adds yet another layer of complexity to the upcoming expedition. The team will be looking for symbolic systems, geometric relationships, astronomical alignments, and architectural proportions that might contain hidden information about the civilization that created these structures. The possibility that the underwater sites might contain encoded knowledge has attracted the attention of specialists in ancient information systems. Dr. Maria Santos has assembled a sub-team of experts in archaeoastronomy, symbolic mathematics, and ancient encoding systems, who will be analyzing every aspect of the structures for possible information content. Dr. Robert Kim, a mathematician who studies numerical relationships in ancient architecture, has been working with the sonar data to identify possible mathematical encoding in the layout of the Spanish site. Ancient civilizations often incorporated important numerical relationships into their major constructions, Dr. Kim explains. These could be astronomical constants, geographical measurements, or even encoded instructions for reconstructing lost technologies. If this site was designed to preserve knowledge, these relationships would be crucial clues. Preliminary analysis of the geometric patterns in the sonar data has revealed several intriguing mathematical relationships. The spacing between the circular formations corresponds to specific astronomical cycles. The proportions of the linear corridors match ratios that appear in advanced ancient mathematical systems. Even the overall layout of the site appears to incorporate geometric principles that weren't supposedly known until much later in human history. But mathematical relationships can also occur naturally, or by coincidence. The real test will come when the expedition team can make precise measurements of the actual structures and determine whether these patterns are intentional or accidental. Dr. Lisa Wang, an archaeoastronomer who studies astronomical alignments in ancient sites, has been analyzing the orientation data from the Spanish site. Her preliminary findings suggest that several of the major structures are aligned with astronomical phenomena that would have been significant 12,000 years ago. The alignments we're seeing correspond to star positions and solar events that would have occurred during the proposed age of these structures, Dr. Wang explains. This kind of astronomical precision would require sophisticated observational capabilities and mathematical knowledge. Astronomical alignments are one of the most reliable ways to determine the age and cultural sophistication of ancient sites. The positions of stars and the orientation of celestial events change over time due to the Earth's axial precession. By identifying which astronomical phenomena a structure is aligned with, archaeologists can often determine when it was built and what level of astronomical knowledge its builders possessed. If the Spanish site really does show precise astronomical alignments corresponding to its proposed age, it would provide strong evidence that the structures are both artificial and incredibly ancient. More importantly, it would demonstrate that their builders possessed sophisticated astronomical knowledge that would have required generations of careful observation to develop. The upcoming expedition will include specialized equipment for making precise astronomical measurements. Laser surveying tools will be used to determine the exact orientations of major structural features. These measurements will then be compared to computer models of ancient sky positions to determine what astronomical phenomena the structures might have been designed to observe or commemorate. But astronomical alignments could also provide information about the cultural and religious beliefs of the civilization that created these structures. Ancient peoples often incorporated astronomical observations into their spiritual and philosophical systems. The specific celestial events that a structure is aligned with can provide clues about what the builders considered important or sacred. Dr. Catherine Lopez, a specialist in ancient religions and cosmology, has been studying the possible astronomical alignments at the Spanish site in the context of what they might reveal about the beliefs and worldview of their creators. Astronomical alignments in ancient structures usually reflect deep cultural beliefs about the relationship between earthly and celestial phenomena, Dr. Lopez explains. If we can understand what astronomical events these structures were designed to observe, we might gain insight into the spiritual and philosophical systems of the people who built them. This cultural dimension adds yet another layer of significance to the upcoming expedition. The team won't just be looking for evidence of advanced technology and engineering capabilities. They'll be searching for clues about the minds and hearts of people who lived over 10,000 years ago. Their beliefs, their values, their understanding of their place in the cosmos. These insights could be just as revolutionary as any technological discoveries. If the underwater structures really do represent the remains of sophisticated Ice Age civilizations, they could provide our first direct glimpse into the intellectual and spiritual life of our most distant ancestors. The questions continue to multiply as the expedition date approaches. Each new piece of evidence opens up possibilities that seemed unthinkable just months ago. The mathematical relationships, the astronomical alignments, the possible symbolic systems, the mythological connections, taken together, they suggest that we may be on the verge of discoveries that will fundamentally change our understanding of human history and human potential. But speculation and analysis can only take us so far. The ultimate answers lie waiting in the crushing darkness of the deep ocean, preserved beneath layers of sediment that have accumulated for thousands of years. In just 6 weeks, advanced submersibles will descend through that darkness and reveal what has been hidden for longer than recorded history. Whatever they find down there, one thing is certain. Our understanding of the human story is about to change in ways we can't yet imagine. The expedition team has completed their final preparations. The research vessel Atlantis has been loaded with the most advanced deep-sea exploration equipment ever assembled for an archaeological mission. The ROV Jason has been equipped with cameras capable of revealing details invisible to the human eye, sampling equipment that can collect materials without disturbing their archaeological context, and analytical instruments that can provide real-time information about the age and composition of whatever they find. But perhaps most importantly, the team has prepared themselves mentally for the possibility that what they discover might challenge some of the most fundamental assumptions about human civilization, human capability, and our place in the long story of life on Earth. In 6 weeks, we'll finally know what's really down there. The countdown continues. As the expedition draws closer, something unexpected has begun happening in research institutions around the world. The Spanish discovery has triggered what marine archaeologists are calling a paradigm cascade, a rapid re-evaluation of evidence that was previously dismissed or overlooked. Dr. James Mitchell, a deep-sea geologist at the Scripps Institution of Oceanography, describes what's been happening in his field. It's like someone switched on a light in a room we thought was empty. Suddenly, we're seeing things that were always there, but we weren't looking for them. His team has been reanalyzing bathymetric data collected over the past 15 years from the Pacific Ocean floor. Using the same pattern recognition techniques that identified the Spanish structures, they've found geometric anomalies off the coasts of Japan, California, and Peru. Each site shows the same telltale signs. Too much regularity to be natural, too much organization to be accidental. But there's something else happening that's even more remarkable. Independent research teams working in complete isolation from each other are reporting similar discoveries at roughly the same time. It's as if the Spanish site has opened a door that researchers around the world are suddenly walking through simultaneously. Dr. Anna Kowalski, working with a Polish research vessel in the Baltic Sea, made her discovery just 3 weeks after the Spanish announcement. Her team was conducting routine sediment sampling when their sonar detected what appeared to be stone circles arranged in perfect mathematical progression across several square kilometers of sea floor. The moment I saw the data, I knew we were looking at something extraordinary, Dr. Kowalski recalls. But what really stunned me was when I compared our findings to the Spanish site. The similarities were unmistakable. The Baltic discovery shares several key characteristics with the Spanish site. Circular formations with consistent spacing, linear corridors connecting major structures, and evidence of sophisticated water management systems. But there are also intriguing differences that suggest these weren't built by the same culture, even if they were created during the same general time period. The Baltic structures appear to incorporate different construction techniques and follow slightly different geometric principles. Where the Spanish site shows evidence of precise astronomical alignments, the Baltic formations seem to be oriented according to magnetic or geographical references. It's as if two different civilizations, working with similar capabilities but distinct cultural approaches, were solving the same fundamental problems of large-scale construction and environmental management. Dr. Erik Johansson, a specialist in ancient Scandinavian cultures from the University of Stockholm, has been studying the Baltic discovery in the context of Northern European mythology. What he's found adds another piece to the growing puzzle of Ice Age civilizations. Norse mythology contains remarkably detailed accounts of advanced civilizations that existed before the Great Floods. Dr. Johansson explains. We've always interpreted these as symbolic stories, but the discovery of actual underwater structures forces us to reconsider whether they might preserve historical memories. The Norse Eddas speak of sophisticated peoples who possessed advanced knowledge of navigation, metalworking, and construction. They describe great halls built upon the sea, engineering projects that spanned vast distances, and technologies that seem almost magical from a medieval perspective. Most intriguingly, they describe the destruction of these civilizations through catastrophic flooding that reshaped the entire world. Dr. Johansson has been working with linguists to trace these mythological accounts back to their earliest forms. What they're finding suggests that some of these stories might preserve technical information about actual engineering projects and construction techniques. Certain passages in the Eddas contain what appear to be detailed instructions for large-scale construction projects, Dr. Johansson notes. They describe techniques for working with stone underwater, methods for creating durable foundations in marine environments, and even what might be early forms of hydraulic engineering. If these mythological accounts really do preserve technical knowledge from Ice Age civilizations, they could provide crucial insights for interpreting the underwater discoveries. The construction techniques described in ancient Norse texts might explain how civilizations 12,000 years ago were able to create the sophisticated structures now being found on ocean floors around the world. But the mythological connections go beyond just construction techniques. Many of these ancient accounts describe civilizations that possessed advanced understanding of astronomy, mathematics, and natural sciences. They speak of peoples who could predict celestial events, navigate by the stars, and manipulate natural forces in ways that seemed miraculous to later cultures. Dr. Rebecca Martinez, a cognitive archaeologist who studies the development of human intellectual capabilities, has been analyzing these mythological accounts alongside the archaeological evidence from underwater sites. What we're seeing is a consistent pattern across multiple cultures and time periods, Dr. Martinez explains. Stories that describe advanced civilizations possessing sophisticated knowledge that was supposedly beyond the capabilities of Ice Age peoples. But now we have physical evidence that such capabilities might actually have existed. The implications of this convergence between mythological accounts and archaeological evidence are staggering. If ancient stories really do preserve memories of advanced Ice Age civilizations, then oral traditions might be one of our most valuable sources of information about these lost cultures. Dr. Martinez has been working with anthropologists and linguists to develop new methods for extracting historical information from mythological narratives. Their approach treats ancient stories not as pure fiction, but as potentially containing kernels of factual information that have been preserved through thousands of years of cultural transmission. We're learning to read mythology like archaeological layers, Dr. Martinez explains. Later cultural additions can be identified and separated from older core elements that might preserve genuine historical memories. This methodology has already yielded some fascinating results. Analysis of flood myths from around the world has identified common elements that appear to describe specific technological capabilities, geographical features, and even astronomical events that correspond to conditions that existed at the end of the last ice age. Most remarkably, many of these mythological accounts describe the same kinds of advanced water management systems that are now being identified in underwater archaeological sites. Stories from cultures as diverse as ancient Mesopotamia, pre-Columbian America, and Aboriginal Australia all mention sophisticated peoples who possessed extraordinary abilities to control and direct water flow. Dr. Susan Chen, the hydraulic engineer who has been analyzing the water management systems in the Spanish sonar data, has been comparing her findings to these mythological descriptions. What she's discovered is keeping her awake at night. The mythological accounts describe hydraulic engineering techniques that match what we're seeing in the archaeological data, Dr. Chen explains. They're not just vague references to people who live near water. They're specific technical descriptions of advanced engineering capabilities. Some of these mythological accounts describe techniques for creating underwater foundations, methods for controlling water flow through complex channel systems, and even what might be early forms of hydraulic machinery. The level of technical detail preserved in these stories would be difficult to explain if they were purely mythological inventions. But perhaps, most intriguingly, several of these mythological traditions describe the preservation of technical knowledge through catastrophic events. They tell of wise individuals or groups who recognized the coming destruction and made extraordinary efforts to preserve essential knowledge for future generations. The Hindu Puranas describe sages who preserved sacred knowledge through cycles of cosmic destruction and renewal. Aboriginal Australian traditions speak of ancestral beings who encoded important information into the landscape itself before disappearing beneath rising waters. Even biblical accounts describe individuals like Noah who preserved not just life, but the knowledge and skills necessary to rebuild civilization after catastrophic events. Dr. Michael Torres, a specialist in cultural memory systems, has been studying these preservation narratives in the context of the underwater discoveries. What we're seeing in these mythological accounts are descriptions of systematic efforts to preserve knowledge through catastrophic events, Dr. Torres explains. If these stories are based on historical reality, then the underwater sites we're discovering might represent some of these preservation efforts. This possibility adds an entirely new dimension to the upcoming Spanish expedition. The team might not just be exploring the ruins of an ancient civilization. They might be investigating one of humanity's earliest attempts to create a permanent record of advanced knowledge and capabilities. The idea that the underwater structures might have been designed as knowledge repositories has attracted the attention of specialists in ancient information systems. Dr. Lisa Park, an expert in how ancient cultures encoded and preserved information, has joined the Spanish expedition team specifically to look for evidence of knowledge preservation systems. If these structures were designed to preserve information through catastrophic events, they would likely incorporate specific features designed to protect and encode knowledge, Dr. Park explains. We need to be looking for symbolic systems, mathematical relationships, and architectural features that might serve as information storage systems. Ancient cultures developed remarkably sophisticated methods for preserving and transmitting important information. The most famous examples include the mathematical relationships encoded in the pyramids of Giza, the astronomical observations preserved in Stonehenge, and the complex symbolic systems used by Mayan civilizations to record both historical events and scientific knowledge. But these known examples all date to much later periods in human history. If the underwater sites really are 12,000 years old and show evidence of information encoding systems, they would represent some of the earliest known attempts by humans to create permanent records of advanced knowledge. Dr. Park has been developing protocols for identifying possible information encoding systems in underwater archaeological sites. Her methods combine traditional archaeological techniques with advanced mathematical analysis and computer pattern recognition. Information encoding systems leave distinctive signatures in archaeological remains, Dr. Park explains. Repeated mathematical relationships, systematic symbolic arrangements, and architectural proportions that correspond to important natural constants or astronomical cycles. The sonar data from the Spanish site has already revealed several features that might represent information encoding systems. The precise mathematical relationships between different structural elements, the astronomical alignments of major features, and the systematic organization of the overall layout all suggest that the site might contain encoded information about the civilization that created it. But detecting information encoding systems in sonar data is just the first step. Actually decoding the information requires detailed analysis of the physical structures themselves. This is one of the primary objectives of the upcoming deep-sea expedition. The team has prepared specialized equipment for documenting and analyzing every possible information encoding system they might encounter. Laser measurement tools will record precise dimensional relationships. High-resolution cameras will capture detailed images of any symbolic elements. Ground-penetrating radar will reveal hidden structural relationships that might not be visible from the surface. Most importantly, the team includes specialists who can recognize and interpret the kinds of information encoding systems that ancient cultures typically used. Dr. Margaret Kim, an archaeoastronomer, will be looking for astronomical information encoded in structural alignments. Dr. Robert Stevens, a mathematician, will be analyzing numerical relationships and geometric proportions. Dr. Jennifer Liu, a specialist in ancient symbolic systems, will be documenting and interpreting any carved or constructed symbols. Working together, this interdisciplinary team should be able to identify and decode any information preservation systems that might exist at the site. If the structures really do contain encoded knowledge from a 12,000-year-old civilization, this could be our first opportunity to directly access the thoughts and achievements of our most distant ancestors. But there's another aspect of this investigation that goes beyond just recovering ancient information. If advanced civilizations really did exist during the Ice Age, and if they developed sophisticated methods for preserving knowledge through catastrophic events, then studying their techniques might provide insights that are relevant to our own situation. Dr. Carl Johnson, a specialist in long-term information preservation who works with government agencies and major corporations, has been following the underwater discoveries with professional interest. Modern civilization faces its own challenges in preserving important information through potential catastrophic events, Dr. Johnson explains. Climate change, nuclear warfare, asteroid impacts, supervolcanic eruptions. There are numerous scenarios where our current information storage systems could be completely destroyed. Understanding how ancient civilizations approach these challenges might provide insights for our own preservation strategies. Current methods for long-term information preservation rely heavily on digital storage systems and technological infrastructure that would be vulnerable to many types of catastrophic events. The stone-based information encoding systems used by ancient cultures might actually be more durable than our modern digital approaches. Dr. Johnson has been working with the expedition team to document any information preservation techniques they might discover. His goal is not just archaeological understanding, but practical application of ancient knowledge to modern challenges. If these underwater sites really do represent successful information preservation systems that survived catastrophic destruction, then understanding how they work could be crucial for ensuring that our own knowledge survives whatever challenges the future might bring. Dr. Johnson explains, this practical application of archaeological research adds yet another layer of significance to the upcoming expedition. The team isn't just investigating the past. They might be uncovering techniques that could be essential for humanity's future survival. As the expedition date approaches, the pressure and anticipation continue to build. The Spanish government has assigned a naval escort to protect the research site from unauthorized interference. International media organizations are preparing extensive coverage of the expedition. Educational institutions around the world are planning to incorporate the live-streamed exploration into their curricula. But perhaps most importantly, the scientific community is preparing for the possibility that this expedition might mark a turning point in our understanding of human history and human potential. If the underwater structures prove to be what the evidence suggests, we could be witnessing one of the most significant archaeological discoveries in human history. Dr. Santos, who will lead the expedition, describes the team's mindset as they prepare for this historic dive. We're approaching this investigation with both scientific rigor and profound humility. We know that what we find down there could challenge some of our most fundamental assumptions about human civilization and human capabilities. We're prepared for that possibility, and we're committed to following the evidence wherever it leads. The expedition is scheduled to begin in just 4 weeks. The research vessel Atlantis is undergoing final equipment checks and crew preparations. The ROV Jason has been tested and retested to ensure it can operate flawlessly in the challenging deep-sea environment. The interdisciplinary team of specialists has completed months of training and preparation. But there's one more element that makes this expedition unique in the history of underwater archaeology. For the first time ever, the entire exploration process will be conducted with complete transparency. Every dive, every discovery, every analysis will be live-streamed to researchers and the public around the world. Dr. Cameron Mitchell, the expedition's media coordinator, explains the reasoning behind this unprecedented openness. This discovery is too important to be limited to a single research team or institution. By making our exploration process completely transparent, we ensure that the global scientific community can participate in interpreting what we find. We also fulfill our obligation to share these discoveries with the public that supports our research. The live streaming technology being used for this expedition represents a breakthrough in real-time scientific communication. High-definition cameras on the ROV will provide crystal-clear images of the structures as they're revealed for the first time in thousands of years. Real-time data feeds will allow researchers around the world to analyze findings as they're made. Interactive features will enable experts to provide input and ask questions during the exploration process. Over 500,000 people have already registered to receive notifications when the live feeds begin. Universities and schools around the world are planning viewing events. Science museums are preparing special exhibitions to coincide with the expedition. The level of public interest in this expedition is unprecedented for an archaeological project. But then again, the questions being explored are fundamental to our understanding of who we are as a species and where we came from. In 4 weeks, we'll finally have answers to questions that have puzzled humanity for thousands of years. We'll know whether the legends of lost civilizations are based on historical reality. We'll understand whether our ancestors were capable of achievements that we've never given them credit for. We'll discover whether the story of human technological development is far more complex and ancient than we ever imagined. The countdown continues, but the anticipation is reaching a fever pitch. Whatever lies waiting beneath 2 miles of crushing ocean water, it's about to change everything we thought we knew about our past, our capabilities, and our place in the long story of human civilization. The expedition team is ready. The equipment has been prepared. The world is watching. In 4 weeks, we descend into the abyss to meet our ancestors face to face for the first time in over 10,000 years. The implications of what we might find down there extend far beyond just rewriting history books. Because if these structures really are the remains of advanced Ice Age civilizations, it means that human technological development wasn't the steady, linear progression we've always assumed it was. Instead, it suggests something far more dramatic, that human civilization has experienced catastrophic collapses and recoveries that we've never fully understood. Dr. Amanda Reeves, a systems theorist who studies how complex civilizations respond to environmental pressures, has been modeling what the discovery of multiple underwater sites could mean for our understanding of human development patterns. If we're looking at evidence of sophisticated civilizations that were destroyed by climate catastrophes 12,000 years ago, Dr. Reeves explains, then we have to consider the possibility that human technological development has been cyclical rather than linear. Advanced capabilities might have been achieved, lost, and then redeveloped multiple times throughout our history. This cyclical model of human development could explain some of the puzzling discontinuities that archaeologists have long struggled to understand. Why do certain technologies appear suddenly in the historical record without the gradual development process we'd expect? Why do some ancient achievements seem to exceed what we think those cultures should have been capable of? The conventional explanation has always been that we're underestimating the capabilities of ancient peoples. But what if the real explanation is that some of these achievements weren't original inventions, but recovered knowledge from much earlier civilizations? Dr. Thomas Chen, a complexity scientist at the Santa Fe Institute, has been developing mathematical models to explore this possibility. His preliminary work suggests that cyclical patterns of technological development could actually be more stable and resilient than linear progression. Linear technological development is vulnerable to catastrophic collapse, Dr. Chen explains. But if knowledge preservation and recovery mechanisms are built into the system, civilizations can maintain their essential capabilities, even through periods of catastrophic disruption. The knowledge preservation systems that might be encoded in the underwater structures could represent exactly these kinds of recovery mechanisms. If Ice Age civilizations really did develop sophisticated methods for preserving crucial information through catastrophic events, those same techniques might have been used repeatedly throughout human history to maintain technological capabilities across multiple collapse and recovery cycles. This possibility takes on new urgency when you consider our current situation. Modern civilization faces numerous potential catastrophic threats: climate change, nuclear warfare, asteroid impacts, supervolcanic eruptions, pandemics. Our digital information storage systems and complex technological infrastructure could be completely destroyed by any number of these scenarios. But if ancient civilizations developed effective methods for preserving knowledge through catastrophic events, studying their techniques might be crucial for ensuring that human technological capabilities survive whatever challenges we might face in the future. Dr. Sarah Kim, a specialist in disaster preparedness and civilizational resilience, has been working with government agencies to develop long-term knowledge preservation strategies. She sees the underwater archaeological discoveries as potentially providing crucial insights for these efforts. Modern information preservation methods are incredibly sophisticated, but they're also incredibly fragile, Dr. Kim explains. A single electromagnetic pulse could destroy vast amounts of digital information. A prolonged power outage could make our storage systems completely inaccessible. We need to learn from civilizations that successfully preserved knowledge through actual catastrophic events. The stone-based information encoding systems used by ancient cultures might actually be more durable than our current digital approaches. Carved symbols, architectural proportions, and astronomical alignments can survive for thousands of years without any technological infrastructure to maintain them. But there's another aspect of ancient knowledge preservation that might be even more important than the physical storage methods. Many traditional cultures developed sophisticated social systems for ensuring that crucial information was passed from generation to generation through oral tradition, ritual practices, and cultural institutions. Dr. Maria Santos, an anthropologist who studies how cultures maintain knowledge across long time periods, has been analyzing these social preservation systems in the context of the underwater discoveries. Physical information storage is only part of the puzzle, Dr. Santos explains. The real key to long-term knowledge preservation is creating social systems that value and protect important information across multiple generations. Ancient cultures that successfully preserved knowledge through catastrophic events had to develop both physical and social mechanisms for maintaining their intellectual heritage. The underwater structures might represent not just physical information storage systems, but evidence of the sophisticated social organizations that created and maintained them. The scale and complexity of these sites would have required coordinated effort from large numbers of people over extended periods of time. The mathematical precision and astronomical alignments would have demanded specialized knowledge and careful training of succeeding generations. If the expedition reveals evidence of these social systems, through symbolic representations, architectural features that suggest ceremonial or educational uses, or organizational patterns that indicate complex social hierarchies, it could provide insights into how ancient civilizations maintained their technological capabilities across generations. Dr. Jennifer Park, a specialist in organizational psychology who studies how complex knowledge systems are maintained over time, has been working with the expedition team to identify possible evidence of ancient knowledge preservation institutions. Complex technological capabilities require institutional support to maintain them, Dr. Park explains. You need training systems to pass on specialized skills, social structures to support expert practitioners, and cultural values that prioritize the preservation of important knowledge. If these underwater sites really do represent advanced civilizations, there should be evidence of the institutional systems that made their achievements possible. The sonar data has already revealed some intriguing hints about the social organization of the civilization that created these structures. The hierarchical arrangement of different structural elements suggests a complex society with specialized roles and sophisticated planning capabilities. The integration of water management systems across the entire site indicates coordinated engineering efforts that would have required advanced project management and social coordination. But identifying the specific institutional systems that supported this civilization will require detailed analysis of the physical structures themselves. The expedition team will be looking for evidence of educational facilities, ceremonial spaces, residential areas that might indicate social stratification, and workshop areas where specialized crafts might have been practiced. Dr. Robert Liu, an archaeologist who specializes in identifying social organization patterns in ancient sites, has developed protocols for recognizing institutional evidence in underwater archaeological contexts. Social institutions leave distinctive signatures in archaeological remains, Dr. Liu explains. Specialized building types, activity areas that indicate particular crafts or functions, spatial arrangements that suggest social hierarchies or ceremonial practices. Even underwater, these patterns should be detectable if we know what to look for. The discovery of institutional evidence could be just as revolutionary as finding advanced technologies. It would demonstrate that Ice Age peoples were not just capable of sophisticated engineering, but also of creating the complex social systems necessary to support and maintain advanced civilizations. But there's another dimension to this investigation that goes beyond just understanding ancient social systems. If the underwater structures really do represent successful long-term knowledge preservation efforts, they might provide a template for addressing one of the most pressing challenges facing modern civilization. How do we ensure that crucial knowledge and capabilities survive potential future catastrophes? How do we create information preservation systems that can function across centuries or millennia? How do we build social institutions that will maintain important knowledge even through periods of civilizational collapse and recovery? These aren't just academic questions. They're practical challenges that governments, corporations, and international organizations are actively grappling with as they try to prepare for potential future catastrophes. Dr. Michael Torres, who advises government agencies on long-term strategic planning, has been following the underwater discoveries closely because of their potential relevance to these modern challenges. If ancient civilizations really did develop effective methods for preserving knowledge through catastrophic events, understanding their techniques could be crucial for our own long-term survival as a technological civilization, Dr. Torres explains. We need to learn not just what they preserved, but how they preserved it and what social systems they used to maintain their preservation efforts across multiple generations. The upcoming expedition could provide the first direct evidence of how our ancestors approached these challenges. The physical structures, the possible information encoding systems, the evidence of social organization. All of these elements could contribute to our understanding of how to create truly resilient knowledge preservation systems. But even beyond the practical applications, the expedition represents something profound about human curiosity and the drive to understand our origins. For thousands of years, humans have told stories about lost civilizations, golden ages that ended in catastrophe, advanced peoples who possess knowledge and capabilities that were later forgotten. These stories have persisted across every culture and every historical period. They've been dismissed as mythology, as wishful thinking, as symbolic representations of universal human experiences. But what if there's something more? What if they're collective memories of actual historical events that shaped our development as a species? Dr. Lisa Chen, a cognitive scientist who studies how cultural memories are formed and preserved, has been analyzing the global prevalence of lost civilization myths in the context of the underwater discoveries. The universality of these stories is remarkable, Dr. Chen explains. Every major culture has traditions about advanced civilizations that were destroyed by catastrophic events. The consistency of these narratives across time and geography suggests that they might preserve memories of actual historical experiences. If the underwater structures prove to be what the evidence suggests, it would validate thousands of years of human storytelling and cultural memory. It would demonstrate that our ancestors were not just creating entertaining myths, but preserving important historical information through the only means available to them: oral tradition and symbolic narrative. This validation of traditional knowledge systems could have profound implications for how we understand the relationship between scientific investigation and cultural wisdom. It might force us to take seriously other traditional accounts that we've previously dismissed as mythological. Dr. Patricia Martinez, who studies indigenous knowledge systems, sees the potential validation of lost civilization stories as part of a broader recognition of the value of traditional cultural knowledge. Indigenous cultures around the world have preserved sophisticated understanding of natural phenomena, historical events, and technological processes through oral traditions and cultural practices, Dr. Martinez explains. If the Atlantis legend turns out to be based on historical reality, it suggests that we should be taking other traditional knowledge systems much more seriously. This perspective adds another layer of significance to the expedition. The team isn't just investigating physical structures on the ocean floor. They're potentially validating entire knowledge systems that have been maintained by human cultures for thousands of years. The implications extend far beyond archaeology. If traditional cultural knowledge really does preserve accurate information about ancient events and capabilities, it could be a valuable source of insights for addressing modern challenges. Traditional ecological knowledge, traditional medicine, traditional engineering techniques, all of these might contain information that could be relevant to contemporary problems. But we're still speculating based on sonar data and stone fragments. The real test will come when the submersibles actually reach the ocean floor and we can see these structures with our own eyes. The expedition timeline has been finalized. In exactly 3 weeks, the research vessel Atlantis will take position above the most promising area identified in the sonar surveys. The ROV Jason will begin its historic descent to depths that have remained untouched by human presence for over 10,000 years. The technical challenges of operating at such depths are enormous. The pressure at 2,300 meters below the surface is over 230 times greater than atmospheric pressure, enough to crush any unprotected human body instantly. The temperature hovers just above freezing. There is no natural light, and the sediment stirred up by the ROV's movements can reduce visibility to near zero. But the technology being deployed for this mission represents the cutting edge of deep-sea exploration capabilities. The ROV Jason has been equipped with the most advanced lighting systems ever used in underwater archaeology, capable of illuminating the structures with daylight-quality brightness. Its cameras can capture images with resolution that exceeds what the human eye could see even in perfect conditions. The robotic arms have been specially modified for archaeological work, with precision controls that allow for delicate sample collection and careful excavation techniques. Ground-penetrating radar systems will allow the team to see through layers of sediment without disturbing the archaeological context. Most importantly, the entire system has been designed for extended operation. Jason can work continuously on the seafloor for up to 20 hours at a time, allowing for detailed, systematic exploration of the site. Dr. James Peterson, the chief engineer for the expedition, describes the technical preparations. We've essentially built a robotic archaeological team that can operate in one of the most challenging environments on Earth. Every system has been tested and retested to ensure we can conduct serious scientific investigation at depths where no human could survive. But technology is only part of the equation. The success of the expedition will depend just as much on the expertise and preparation of the human team directing the robotic exploration. Dr. Santos has assembled a team that represents the pinnacle of expertise in underwater archaeology, ancient engineering, materials analysis, and information systems. Each team member has spent months studying the sonar data, developing protocols for their specific area of investigation, and preparing for every possible scenario they might encounter. The team has also prepared for the possibility that what they find might not match any of their expectations. Ancient civilizations often developed solutions to engineering challenges that are completely different from modern approaches. The expedition team is prepared to encounter construction techniques, materials, and organizational systems that don't fit any known historical patterns. Dr. Sarah Kim, the expedition's chief archaeologist, emphasizes the importance of maintaining scientific objectivity. We have to be prepared to follow the evidence wherever it leads, even if it challenges our most fundamental assumptions about ancient human capabilities. Our job is not to confirm any particular theory, but to document and analyze whatever we actually find down there. The live streaming component of the expedition has generated unprecedented public interest. Educational institutions around the world are planning viewing events. Science museums are preparing special exhibitions. Major news organizations are dedicating significant resources to covering the expedition. But the research team is also aware of the pressure that comes with this level of public attention. Millions of people will be watching their every move, forming their own interpretations of what they see, and debating the implications of every discovery. Dr. Mitchell Cameron, the expedition's communication director, has worked with the team to develop protocols for presenting their findings in a way that maintains scientific accuracy while also being accessible to public audiences. We want people to understand not just what we find, but how we interpret it and what level of confidence we have in our conclusions, Dr. Cameron explains. Science is a process of careful analysis and peer review, not just dramatic discoveries. We want the public to see how that process actually works. The expedition will also serve as a real-time educational experience, demonstrating how modern archaeological research is conducted. Viewers will see how evidence is collected, how hypotheses are tested, and how scientific conclusions are reached through careful analysis of multiple types of data. But perhaps most importantly, the expedition represents a moment when humanity might finally answer some of the most fundamental questions about our origins and capabilities. Are we the first technological civilization to emerge on Earth? Or are we part of a longer, more complex story of human development? Did our ancestors achieve levels of sophistication that we've never recognized? Are the legends and myths that have been passed down through thousands of years of human culture based on actual historical events? In 3 weeks, we'll begin to find out. The research vessel Atlantis is completing its final equipment checks. The ROV Jason has been tested in conditions that simulate the deep-sea environment it will encounter. The interdisciplinary team of specialists has rehearsed every aspect of the exploration process. But there's one more element that makes this expedition truly historic. For the first time in human history, we have the technology to systematically explore the parts of our planet that have been hidden beneath the waves since the end of the last ice age. We're about to search areas that could contain the remains of civilizations that existed when the world was a completely different place. Sea levels were 400 feet lower than they are today. Vast areas of what are now ocean floor were dry land with rivers, forests, and coastal plains. The climate was different, the geography was different, and the opportunities for human civilization were different. If advanced civilizations did exist in those lost landscapes, their ruins are waiting for us in the deep ocean. The Spanish site might be just the first of many discoveries that will force us to completely reconsider the story of human civilization. Dr. Santos, standing on the deck of the research vessel as it prepares for its historic mission, reflects on what they might be about to discover. We're on the verge of potentially rewriting the entire story of human technological development. What we find down there could change everything we thought we knew about our ancestors, our capabilities, and our place in the long history of life on Earth. The countdown has reached its final phase. In 3 weeks, we descend into the abyss to confront mysteries that have waited over 10,000 years to be solved. Whatever we find down there, human history will never look the same again. The final preparations are complete. In just 72 hours, the research vessel Atlantis will reach the coordinates that have consumed the scientific world's attention for months. But as the expedition enters its final countdown, something extraordinary has begun happening in laboratories and research institutions around the globe. Dr. Elena Vasquez received the call at 3 a.m. on a Tuesday morning. Her voice was barely above a whisper as she described what her team had discovered in their latest analysis of the stone fragments recovered by the fishing vessel. Using advanced electron microscopy, they had identified microscopic tool marks that shouldn't exist, precision cuts that would require technology we didn't think existed 12,000 years ago. But that wasn't all. Embedded within the stone matrix were organic materials, fragments of wood, plant fibers, even what appeared to be processed textiles. The preservation was remarkable, protected by the unique chemical environment of the deep ocean. And when they ran carbon dating on these organic materials, the results stopped everyone in their tracks. The dates were consistent. 11,147 years, plus or minus 200 years. Almost exactly the time frame that Plato had given for the destruction of Atlantis. Dr. Rodriguez, the materials scientist who had identified the bronze particles, was working around the clock analyzing new samples. Each test revealed more sophisticated metallurgy than the last. Not just bronze, but evidence of controlled alloying techniques that produce materials with properties specifically designed for marine environments. These aren't random metal fragments, Dr. Rodriguez explained to the assembled expedition team during their final briefing. These are engineered materials designed by people who understood the challenges of building in and around water. The corrosion resistance, the structural properties, even the aesthetic qualities, everything suggests a level of metallurgical sophistication that we associate with much later periods of human development. But perhaps the most stunning discovery came from Dr. Liu, the specialist in ancient symbolic systems. Working with high-resolution images of the carved symbols on the stone fragments, she had begun to identify patterns that suggested something unprecedented. "These aren't random decorative elements," she announced to the hushed conference room. "They appear to be part of a systematic notation system, possibly one of the earliest forms of mathematical or astronomical recording ever discovered." The symbols showed clear evidence of positional notation, geometric relationships, and what appeared to be astronomical observations. Some of the markings corresponded to celestial events that would have been visible 12,000 years ago, but are no longer observable due to the precession of Earth's axis. If these interpretations were correct, the people who created these symbols possessed mathematical and astronomical knowledge that rivaled achievements we don't see again until the classical civilizations of Greece and Babylon. Thousands of years later, Dr. Chen, the cognitive scientist studying cultural memory systems, had been analyzing these discoveries in the context of oral traditions from around the world. What she found added another layer of validation to the emerging picture. The technical details preserved in mythological accounts match what we're seeing in the physical evidence, she explained. Stories that describe advanced metallurgy, sophisticated astronomical knowledge, and complex engineering capabilities. We've always assumed these were symbolic or exaggerated, but the archaeological evidence suggests they might be surprisingly accurate historical records. As the final hours ticked away before the expedition's departure, the implications of these discoveries were sinking in. This wasn't just about finding ruins on the ocean floor. They were potentially about to make contact with a civilization that possessed capabilities we had never imagined our ancestors were capable of achieving. Dr. Santos stood on the deck of the research vessel, watching the sun set over the Atlantic Ocean. Somewhere beneath those waves, structures that had remained hidden for over 11 millennia were waiting. In less than 3 days, human eyes would see them for the first time since the catastrophic floods that ended the last ice age. The technology was ready, the team was prepared, the world was watching. But as the expedition entered its final phase, one question echoed in everyone's mind. What if what they found down there was so far beyond current understanding of ancient human capabilities that it forced a complete reconceptualization of our species' technological journey? The answer lay waiting in the crushing darkness of the deep ocean, preserved beneath layers of sediment and time. In 72 hours, the most advanced underwater exploration technology ever assembled would descend through that darkness to reveal secrets that had been hidden longer than recorded history. Whatever they discovered would change everything. The story of human civilization, the understanding of our ancestors' capabilities, the very timeline of technological development, all of it was about to be rewritten. The countdown had reached 0. As the research vessel Atlantis positioned itself above the target coordinates, a strange calm settled over the expedition team. Dr. Santos stood in the control room, surrounded by banks of monitors that would soon display images from a world that had been dark for over 11,000 years. "Jason is descending," announced Dr. Peterson, his eyes fixed on the depth readings. "Passing through the twilight zone now, 2,000 meters to go." The remotely operated vehicle fell through layers of crushing water, its powerful lights creating a small bubble of illumination in an ocean of absolute darkness. Fish scattered from its path, deep-sea creatures that had never known sunlight, living their entire lives in the perpetual night of the abyss. As Jason approached the seafloor, the sediment began to swirl in its lights. For a moment, visibility dropped to almost nothing. Then, as the disturbance settled, the cameras began to reveal what lay beneath. The first images were unremarkable. The typical muddy bottom of the deep ocean, covered with the accumulated debris of millennia. But as Jason moved forward, following the coordinates provided by the sonar mapping, something began to emerge from the sediment. A straight line, too straight to be natural. Dr. Santos felt her breath catch in her throat. "Move the camera down the length of that feature," she instructed. As Jason followed the linear formation, more details became visible. The line wasn't carved into the seafloor, it was raised above it, like a buried wall or foundation slowly revealed by ocean currents over thousands of years. "We're getting readings from the ground-penetrating radar," Dr. Kim announced. "There's definitely something substantial beneath the sediment. The structure extends down at least 15 meters. But it was when Jason reached the end of the linear feature that the expedition team fell silent. Rising from the seafloor, partially buried but unmistakably artificial, was a circular formation, exactly matching what the sonar had detected months earlier. The structure was massive, nearly 100 meters across, and built from blocks of stone that had been fitted together with a precision that defied explanation. Even after 11 millennia underwater, the joints between the stones were so tight that sediment had barely penetrated between them. Dr. Alvarez, the stoneworking specialist, was the first to speak. "Those blocks had to weigh several tons each. Moving stones that size requires sophisticated engineering, cranes, ramps, coordinated teams of workers. This isn't the work of a small group of people. This is evidence of a complex, organized civilization." As Jason's cameras panned across the structure, more details emerged. The blocks weren't simply stacked, they were carved with the same symbolic patterns that had been found on the fishing vessel fragments. The symbols were everywhere, covering nearly every visible surface with geometric designs and notations that spoke of mathematical sophistication. But perhaps most remarkably, the structure showed clear evidence of the water management systems that the sonar had detected. Channels carved into the stone directed water flow around and through the formation, creating a network of controlled currents that would have required advanced understanding of hydraulic principles. Dr. Hartman, the hydraulic engineer, was analyzing the water channels in real time. "This is extraordinary," he said, his voice filled with wonder. "These channels aren't just decorative, they're functional, designed to control erosion, manage water pressure, even create specific flow patterns. The level of engineering sophistication is comparable to Roman aqueducts, but this predates Roman civilization by over 8,000 years. As the exploration continued, Jason revealed structure after structure, each more sophisticated than the last. The circular formations were connected by the linear corridors that the sonar had detected, creating a vast network that stretched across several square kilometers of seafloor. And at the center of it all, Jason's cameras revealed something that left the expedition team speechless. Rising from the seafloor like a mountain, partially buried but clearly artificial, was a structure of such scale and complexity that it defied every assumption about ancient human capabilities. It was a pyramid. Not the stepped pyramids of Central America or the smooth-sided monuments of Egypt, but something entirely unique, a structure that seemed to blend architectural elements from multiple traditions while predating them all by thousands of years. Dr. Santos stared at the monitors in stunned silence. The implications were staggering. If this really was what it appeared to be, a sophisticated architectural complex built by an advanced civilization over 11,000 years ago, then everything they thought they knew about human development would have to be reconsidered. The pyramid wasn't just large, it was precisely engineered. Its sides rose at exact angles that created specific geometric relationships. Its surface was covered with the same symbolic notations found throughout the site, but here they were arranged in patterns that suggested astronomical observations and mathematical calculations of remarkable sophistication. As Jason circled the structure, its cameras captured details that would be analyzed for years to come. Water channels that directed flow in specific patterns, stone blocks fitted together with tolerances that would challenge modern construction techniques. And everywhere, the symbols, a written language that might represent one of humanity's earliest attempts to record advanced knowledge for future generations. Dr. Park, the information systems specialist, was working frantically to document every symbol, every geometric relationship, every architectural detail that might contain encoded information. If this structure really was designed to preserve knowledge through catastrophic events, she said, then we might be looking at humanity's first library, a repository of information that's been waiting over 10,000 years to be read. The live stream of the expedition had attracted over 2 million viewers around the world. In universities, museums, and homes across 6 continents, people watched in real time as human history was being rewritten before their eyes. But for the expedition team, the true magnitude of their discovery was just beginning to sink in. They weren't just looking at ancient ruins. They were witnessing evidence of human capabilities that predated known civilization by millennia. Capabilities that had been lost to catastrophic climate change and only now, with the most advanced technology available, were being rediscovered. As Jason continued its exploration, one thing became clear. The Spanish site wasn't an isolated anomaly. It was evidence of a lost chapter in human history, a chapter that had been written in stone and preserved beneath the waves, waiting for the day when humanity would develop the technology to read it once again. The expedition was far from over, but already its implications were reverberating through the scientific community and beyond. The questions that had driven human curiosity for thousands of years were finally being answered, and the answers were more extraordinary than anyone had dared to imagine. In the crushing darkness of the deep ocean, illuminated by the lights of advanced robotic explorers, the lost world of our ancestors was finally revealing its secrets. And with each new image transmitted to the surface, humanity's understanding of its own story was being transformed forever. The countdown had ended, but the real journey into our forgotten past had only just begun.